In this example, we'll be using a hypothesis test for a population proportion. It's a quality control scenario. A candy company is trying to make a claim about their product, and they need the proportion of packages to be at least, in this case, 80%, 0.8 of the packages. That proportion must contain 3 ounces or more of chocolate stars. So getting the spreadsheet, make sure you're using the correct sheet. I'm going to be using sheet 4. So the data is here in the first column, and you could go through and just count how many packages in the sample weigh in at more than 3 ounces, and then that would help you find the proportion of your sample. But I'm going to use a formula here rather than counting. And so what I'm going to do here is divide everything in that first column by 3. So we're looking for what weighs more than 3 ounces. And if you divide by 3 and it is a value less than 3 ounces, you get a number here less than 1. If it's a number that's more than 3 ounces, you get a number that's greater than 1. All right, so let me go ahead and copy that all the way down. So you can see anything less than 3 ounces, I'm getting a number less than 1. Anything greater than 3 ounces, a number larger than 1. So there's a formula in Excel called INT here. And let me just go ahead and do it in the next column here. So equals INT. And I'll take the integer there. And what this integer function does is it rounds down. So anything less than 1 is going to round down to 0, so I won't count it then as a package that weighs more than 3 ounces. Anything larger than 1 will round down to 1, so I will count it as one package that weighs more than 3 ounces. So I copy that all the way down, and I have a 1 for every package that weighs more than 3 ounces and a 0 for every package that weighs less. Now I can just add up that column and see how many total packages there are that weigh more than 3 ounces. One thing you do want to check is make sure it's all zeros and ones. You could possibly get a 2 if one of your packages weighed 6 ounces or more, which we don't have that anywhere in our sample here. We don't have anything with 6 ounces or more of chocolate stars. That'd probably be very unlikely since the company's trying to get closer to 3. If you had a 2 showing up, just click on that cell and change it manually to a 1 because you just want to count that package one time. You don't want to count it twice. But anyways, then you sum that entire category. Let's count up all those values there. And it seems there were 36 packages in my sample that weighed more than 3 ounces. So the first question here is, what is the sample proportion? So I'll take how many weigh more than 3 ounces out of my sample size. My sample proportion is 0.72. And then we need to find the z-score and the p-value for this sample. And so then back up at the top here of the book, here's how we're going to find the z-score. Copy that over here for reference. Do the top and bottom separately. I think that just makes it easier. So for the top, I do my sample proportion, so 0.72, and subtract my null hypothesis, which in this case was that 80% of the bags have 3 ounces or more. And so then for the bottom, I need to do the square root here. And you know what I'm actually going to do, split this up because there's a lot of parentheses and you have to type it in perfectly to get this bottom part right. I'm going to do the top and bottom here of the bottom. So kind of make a sub thing. So for this bottom part, what is the top part? It is my population proportion, 0.8 times 1 minus 0.8. All right, and what is my bottom? It is the sample size, which is 50. Okay, so I now can do the square root. So I'll do that whole square root thing equals the square root of the top divided by the bottom. So this is my value for the entire bottom the square root of the top divided by the bottom. And this is the top part. So if I'm trying to get that z-score now, I can just do what is on top and divided by what I have listed here as this entire square root that goes on bottom. So negative 1.41. And so what is the p-value associated with that z-score? Well, we need to make sure we're doing correctly the left tail, the right tail hypothesis test. We're trying to determine from our sample if the proportion is less than our null. So our alternative is less than, and we're doing a left tail test. And so we can just use the formula norm.s.distribution, click on our z-value and type true, and this gives the left-tailed p-value. And there we have it. If we were doing right-tailed, we use that same formula, but we do 1 minus the result, and it gives them the probability of being to the right, as opposed to the probability of being to the left of our particular z-score. So I'm going to help get started through the next one as well. Talk a little bit more about how to quickly count in Excel how many values in your sample meet a certain criteria. So in this case, we're looking at people with more than $50,000 in debt. I'm using sheet 1. So I can use that same approach. I'm going to take that first value and divide by 50,000. Anybody with less than 50,000 in debt, it's going to come out to a number less than 1. Anybody with more than 50,000 in debt is going to be a number more than 1. But you see, we are getting some negatives in this example. I assume that's somebody without any debt. They just have some savings. So let me drag that all the way down. You can use that same function though. int, it rounds down to the nearest integer. And if you drag that all the way down, you're going to have a bunch of zeros and ones. You want to make sure there's no twos. Anybody with a 2 they have 100,000 or more dollars in debt. So when you divide by 50,000, you're getting a number larger than 2. Manually change those to a 1. Anybody with a negative, you want to manually change to a 0 because they have no debt whatsoever. So that's one way you can do it, and then sum up how many people there are, how many ones you have in that column. But I did want to show one other way to do this. A formula is called if. So we're going to write a condition, and Excel is going to return either a 0 or a 1 based on our condition. So if, and here it says you need a logical test. So my test is going to be, is the value there in A1 less than 50,000? Don't want to put a comma there. Less than 50,000. If so, I want to return a 1. I want to count that person. And if not, if it's more than 50,000, I want to return a 0. Oh, that's backwards. We're trying to count how many people have more than 50,000. So if it's greater than 50,000, I want to count that as 1. And if it's not greater than 50,000, I'll count that as a 0. So you should see you're getting the same results here. You're getting the ones everywhere. We had a 1 in that column and zeros everywhere as well. And you don't have to worry about the negative people because anybody who has a negative value, they fall into the same category as anybody else less than 50,000, and it's going to return a 0 here. And you also don't have to worry about checking for 2s. Anybody at all with more debt than 50,000, whether it's a little bit more or a lot more, it's just going to return a 1 if it's greater than 50,000 in debt. So there's no additional checking to do after you use this formula. You just have the correct zeros and ones, and you can use that sum function then to count your ones. So I could have done the same thing with over here, that first problem I did. And this is probably a better way because there's less to check afterwards. So if that first column, if you get a value greater than 3, you want to count that bag. And if it's less than 3, you don't want to count that bag in your sample. So if it's greater than 3, then comma 1, comma 0. And when you drag that down, you're going to see This is giving the same results that we got doing that method I showed earlier in the video. You're getting 1s for every bag weighing in over 3 ounces and a 0 if it weighs in less than 3 ounces.